That'd be really nice. You can change your chat nickname anytime. Wow. Chat nickname. Ooh, my phone. What is the text message?
Relax. Guys, look at my dog's face on
No, I love your dog.
Your dog
I feel bad for him.
Okay, so where do we leave off? Let's take a look. We have 30 over here. I think we did get a little further during period 4 than we got in period 1. So we're going to have to do a little bit of review. We did 31 in both classes, so I think we need to go to 32. Let's take a look at 32. I have the wrong sheet of paper here. I have calculus. What I'd really like to hear is myself talking. And 32 says, what x and y are independent in the probability tables above. What is the probability of x equals 2 and y equals 12? And so because it says they were independent, all I need to do is multiply. Oh, yeah. You probably want to see. I don't want you to live through your life like you're blind.
How was your weekend, Mr. Freeman?
It was wonderful.
You're so good.
Saturday morning, I woke up and I cleaned the bathroom.
Oh,
Right.
yeah.
All based on
At
That's
least you weren't
so
the
yeah.
ACT.
Oh, okay, so 30.
Huh?
At least you weren't at the ACT.
Yeah.
At the AT.
No, I had fun at the ACT.
Oh, I would love to take an ACT
Yeah, right? Come on. No.
because it means nothing to me. So yeah.
Dude, ACT
So you just
sucks.
want to waste like 4 hours of your life? Like, just
Trust me, I work here.
Apparently Luba, tell the story. The girl who was like, I don't have time for
Oh
this.
yeah, we were there and this girl was like, first of all, this one girl already passed the test and she was like, actually, I don't want to take it. And the prompter was like, what? And so she just got up and left. And then, or she already passed. And then this other one was like, I don't have time to take the writing portion. And she was like, what do you mean, like the writing portion room? She's like, I don't have time to take it. And then so she just got up and left.
Well, isn't the writing portion optional?
No, you
Not if you
once
sign up for it.
you sign up for
it.
it.
Anyways,
Wait,
32, because like, I want to do this. 32, we're scoring the ACT.
Awesome.
I wish
Okay.
I was not class.
All right. To solve for y equals p equals 12, the probability of p equals 12. You have to remember that all the probabilities in the y chart, that's that second chart, they all have to add up to 1. So we have 1/6 plus 1/3 plus a question mark plus 2/5 is equal to 1. Should you do some mathematics, you're going to get that question mark is actually 1/10. So, any questions on that?
Wait. We're not, yeah.
It's 30? 32.
Okay, 32, we have the probability of 10 is 1/6, the probability of 11 is 1/3, the probability of 12 is not explicitly given. In fact, you're given a question mark. And the probability of 5 is 2/5. You need to figure out the value of that question mark. So all of those 4 probabilities, including the question mark, need to add up to 1. So let's see. 1/6 plus 1/3 is 1/2. 1/2 plus 2/5 is 9/10. Okay. So that question mark has to be 1/10.
How do you know that?
All the probabilities in the y chart have to add to 1. 1/6 plus 1/3 equals 1/2. 1/2 plus 2/5 is 9/10. 9/10 plus a question mark, it has to be equal to 1. The question mark is 1/10.
Thank you.
So the last part of that 32. the
I'll get
answer is-
there.
Okay.
Get there. So the probability of y equals 12 is equal to 1/10. So let's go backwards then. The probability of x equals 2 and y equals 12 is equal to the probability of x equals 2 times the probability that y equals 12. That's only true because of independence. Okay, probability x equals 2 is 0.25. Probability that x equals 10 is, that y equals 12 is 1/10. 1/4 times 1/10 is 1/40. Fini.
What would you do if it wasn't independent?
You would need a lot more information than I just gave you.
Okay, I think I've already asked this.
Yeah. You can't answer this question unless they're independent.
Okay.
Adam? Did I answer your question?
Yeah, yeah.
Okay. Good. Anything else on 32? Okay, 33. Considering the following sets of data, which observations are outliers using the 1.5 times IQR rule? Okay, first of all, we have to figure out the IQR. Okay. Let's see. How many observations are there?
14.
There are 14. Okay, so the bottom 7 are the lower half. What's the median of the bottom 7?
What's the median?
The median should be 19, right?
Yeah.
Okay, so median of the bottom half is 17. So 17 is Q1.
Isn't it 19?
Is it 19?
Yes. There's no 17.
Oops.
It's okay.
Thanks. Median of the upper half,
32.
32. And that's going to be Q1, Q3, I mean. IQR is equal to 32 minus 19, which my calculator tells me is 13. 1.5 times IQR is then going to be equal to 13. Sorry, 1.5 times 13. Yeah.
To find that median of the bottom half, are you plugging into your calculator or are you doing that?
I'm doing it.
How do you do it?
You just divide it in half. The
How you divide in
ob-
half?
observations in half. Okay,
Oh.
lower half and bottom half. Lower half and upper half. Then you find the median of the lower half.
Oh, okay, that's easy.
It's literally what it is.
Okay.
It's being very literal. Okay, so low outliers
That's any. Oh.
must be less than Q1 minus 1.5 IQR. This is the formula. So low outliers must be less than what was Q1? 19 minus 19.5. So must be less than negative 0.5. Okay. None of the observations are less than negative 0.5. Okay. High outliers must be greater than Q3 plus 1.5 times IQR. So high outliers must be greater than Q3 is 32.
Yeah.
1.5 IQR is 19.5. Okay, 51.5. Are any observations greater than 51.5? Good. 68 is greater than 51.5. Therefore, 68 is a high outlier. That's the only outlier. Okay, yeah.
I'm confused. Not confused, but like, how did you find the median of all of it? So like, how do you know when to separate the Q1 and Q3 when the median isn't even?
Well, the median would be the middle of the
Middle two numbers.
the middle two numbers, which I don't remember. I think they were 23 and 28.
Okay, so
Okay.
would you include the 23 in Q1?
You would
You would
in the
include
lower half.
it in the lower half.
Hmm. Because the median is going to be, I think in this case it's 25.5.
Okay.
So you don't include the median, but you include all the numbers that are less than the median.
Okay, so you would include the 23 in Q1 and you include the 28 in
Yeah,
Q.
let's rephrase that. You would include 23 in the lower half,
Yes.
and you would include 28 in the upper half.
And if it was an odd number and the middle number is 15, you don't include that.
You don't include that in either half, yeah.
That makes sense.
Okay.
Thank you.
Calculator, let's talk about that while we're at it. Let's input the list into our calculator.
Let's do it.
Shit, I forgot it.
Stat. Edit. I'm going to clear my lists. What is that? 4, 5, 12, 19, 19, 22, 22, 23, 8, 8, 2. 38, 49, and 68. Alright, so that's all of my observations. You're going to hate me for doing this, I think. Is that really a 4? Yeah, 4 and 5. Okay, and I'm going to go to statplot. Going to turn this on. And I'm going to turn it into a box plot, the modified box plot. List 1, frequency, mark, everything looks good. Going to zoom, and I'm going to zoom 9, stat. Zoom 9, stat. Oh, I still have some calculus left there. I'm going to actually get rid of that. Oh, look, there's more calculus. That's not cool. Alright, I'm going to actually turn those graphs off, so I don't see them. Actually, I should just clear them. Let's clear them. Okay, so here's my modified box plot, and this is why I said you're going to kill me about this. Because if you just put the numbers in your list, it'll show you the outlier. I have one outlier.
Wait, can you go back to your class?
Yeah, I will. In fact, I'm going to copy and paste my calculator.
I thought totally
Mine's not showing that outlier.
same.
Yeah.
Oh, you're probably not using a modified box plot.
Zoom 9. It's modified box plot the
It's the
first
fourth
option.
one.
Put it over. Pretty sure I did.
Oh, like
Is it the first one or the second?
No, you're right. You're right.
second.
Or fix your window.
Got it.
It looks like I have an ugly mess here.
Which one is it? The first one?
It's the fourth one.
Yeah, that's the one I chose.
Oh, there it is.
The first
We
one.
use
No, not that one. The other one.
Right?
Oh, I see. I see.
I'm so worried that you... So worried if we don't know that.
No, I know it. I just want to make sure.
Here's the outlier. Look, Ma, an outlier.
Yeah, that's the outlier. How come you hit trace?
Outlier.
I don't get it.
Okay? Okay. Let's take a look at question 34. And I'm not sure where this belongs.
Yeah.
Sorry, that's for this one right here, right? Whoa, what did I just do? Alright, I just have to redraw that, that's fine. Okay, taking a look at what I have for 34. We want to know if we combined our turtles together, what kind of distribution are we going to have? Well, we're combining two normal distributions. I know the normal because it says at the very last sentence, assume the snapping turtles and Atlantic green turtles have normally distributed weights. Okay, that's great. So in other words, if I want to know the average weight, I just need to add the two averages together. Done. Average of a snapping turtle and a green turtle together would just be the average snapping turtle plus the average of the green turtles. That adds up to 223 kilograms. I can't remember how many pounds that is. How many pounds is 223 kilograms?
It's about 100.
Okay, give me a moment. 223 kilograms converts to about 492 pounds.
Yeah, Luca, you were close.
Dude, I was almost close.
Almost.
I was like 300, just 300. I confused
You
you.
did this in period 4. I was like,
It was horrible. You have to speak clearly to Siri.
I feel bad for people that accent.
oh, so you can never understand
Whatever,
my mom.
my
My
mom,
mom was
CD, book ease.
and then I'll say it to Siri, and I'm like, how come she understands you and not me?
She's like, why doesn't CD understand me?
I thought they did.
No, it's alright. My mom's accent is just random.
But Siri doesn't understand my mom either, so it's cool. Okay, now the tricky one here is the standard deviations. So you have to remember that you cannot play with standard deviations. You have to go through the variances.
Why do you do variances?
So the variance of the snapping turtles plus the variance of the green turtles is equal to the variance of a snapping turtle and a green turtle combined.
And then variance is just standard deviations.
Yeah.
I know you answered this before, but why do we square it again?
Because we have to look at the variances.
So when
You're out of
would we
81.
square, are you not gonna name it?
When you're trying to go from variance back to standard deviation. We do that right here. We found out the variance of this is 232. We square root it to get it back to the standard deviation. So my standard deviation is 1523 kilograms, which, if I'm doing this correctly, is about 30 pounds.
Wait, so is it because we can't like add standard deviations?
You cannot play with standard deviations. You can play with variances all you want, but you can't play with standard deviations. Yeah.
I know for Z.
Can't never play with deviance.
I know for Z score you cut it off after 2 decimal points, but do you round or do you?
Always, this is a rounding class.
Round.
You can't calculate standard deviation, so we found the variance, so we squared the standard deviation, added them up, and then he squared.
So wait, so Z scores 2 probability
squared the standard deviation.
So Z scores 2 decimal points.
Always.
Probability is always 4.
It's in the problem, it says.
Z scores 2 decimal points.
Okay.
I'm being really stupid right
Any others with 34? Can we go to 35? 35.
Square it is the variance. Square the standard deviation is a variance.
Yes. Don't play with deviance.
What does that mean?
That means you can't find this, you can't use a squared
You can't add standard
to
deviation.
find, that thing at the bottom.
Use your words.
You can't add.
I can't do it right now.
It's a lot of pressure, right?
Find the normal distribution, right? You can't use a square deviation. Find the normal distribution.
You're like confusing everything.
Hey, Brett, do a variance with the
Let's take a look at 35. This one's kind of strange. Okay, it's not really strange, but the idea here is that how do I say this without offending your sensibilities? I'm so tempted to say something really inappropriate when you said that.
Do it. Just
No.
stop
Are you
recording.
kidding? No.
Come this microphone.
No. I'm a proper person.
Are you?
No,
Yeah.
he's just saying this because he's recording it.
Of a new distribution.
I'm a proper person.
We're all proper.
Thank you.
For you, man.
Okay, so here's the idea. We want to know the probability of rolling a 7 given that you know one die is a 6.
1 6.
Okay? Okay, so this is a conditional probability. In order for you to do this, you're going to have to use the conditional probability rules. So the probability is going to be equal to the probability of getting a sum of a 7
Given.
and one die is a 6 divided by the probability that one of the die is a 6.
So it's the given thing, right?
Yes.
But why is it 2 over 36?
Okay. So the question is, how many different ways can I get a sum of 7 and have one die be a 6?
1 and 6 and 6.
Exactly.
Only 2.
There's only 2
But
out of a 36 total combinations.
didn't we say in 4th period that it was going to be only 10 out of 36?
Yeah, we did, but I think the idea with this one is that one
Is it
die
at
being a
least
6 includes 2 dies being 6.
Okay. So it is 11 out of
So it is 11 out of 36. Okay, now the probability that one die is a 6, you have to be able to count all of them. How many different outcomes have 1/6 die? 1 6, 2 6, 3 6, 5 6, 6 6, 6 1, 6 2. Not 6 6 again, yeah. So that's 11 different outcomes. You know what? I think we're, in order to make it match with the study guide, they're looking at 6 6 being an instance of one die being a 6.
So,
Well, it's just kind of interpretation question. When you say one die is a 6, do you mean exactly one die is a 6? Or do you mean that as long as there's a die that shows a 6?
It means at least one die is 6.
Yeah.
You know, you can get an outcome of 1 6, or you can get an outcome of like one die is 1, the other one's 6, or the other one is 6 and the other one's 1.
yeah.
So, do you
There's
think?
2 probabilities out of 36.
I don't understand what you're doing. You're doing conditional.
Yep. This is a conditional probability. So
So the 2 out of 36 is 7 and. It's
One
the
die is a
7
6.
And 1 die is a 6. Okay.
Wait. Then
and then we just counted there are 11 outcomes that show a 6.
Okay.
Okay? So 2 out of 36 divided by 11 out of 36, that's 2 out of 11.
Wait, what's the 2 out of 36?
1 6 6 1 out of 7.
There are 2 outcomes that have a sum of a 7 and have one die being a 6. Maybe I should write this like this.
6 1 and then 1 6.
There you go. Should write it like that.
And then the sum of it being a 7 is 1 out of 6.
Hmm?
Right? Yeah. And then that's how you get the 2 because you do 1 6 and 2 6. Is that what it is?
So then why do you have the 11 out of 36, which is the what the probability?
Because there are 11 outcomes that show a 6.
And then you're taking the 2 that are going to add up to being a 7 out of the 11.
How many?
Exactly.
2 ways.
Two
They
ways.
just both happen to be ways where one of them is a 6. With a 6.
Come on, equality.
6 1 and I don't understand this probability though.
Okay, let me explain it to you.
Like,
She's like, I had enough of this.
since the probability
Alright,
is
let's
2 out of
go.
11.
Good morning.
Wow, you decided to join us, huh?
I have to go home and get my
Thanks.
Leave Brittany alone.
Your Britney
You ever
Spears.
seen that video?
It's fake. She's really rich. Shut up.
Brittany, if you're going to come in late,
Yeah,
just
I'm
sit down
there.
and
I'm
stop
trying
making
to
so
do
much
it.
noise.
I don't exist.
City chick.
Sharon's the real district.
Yeah, we can. Everyone good with 35?
Yes, sir.
Yes, sir.
Okay, 36. Arena scores 42 in quiz 1. The average of quiz 1 was 32 with a standard deviation of 10. She scores 40 in quiz 2. The standard average and standard deviation are 35 and 3. Relative to the rest of the class, which quiz does she do better on? Assume the quizzes are normally distributed. So what we're looking at is the phrase relative to the rest of the class. Okay. That means look at z-scores. Okay, so the first z-score, the z-score for test 1, that's going to be her score, which was 42, minus her standard deviation, which was,
No, isn't it? It's
no, minus this average, which was
32/10.
divided by the average, which was 10,
No, divided by standard deviation,
divided by standard deviation, which is 10.
which equals.
It's okay.
I love Sharon.
Equals,
I'm sorry. I didn't even.
is it 1? Yes, 1. Okay. Oh, is there one over there? I don't think that's, no, that's not a study guide. Is this it? No, that's,
If only you were a little bit more responsible.
I wasn't there when you passed out.
okay. Quiz 2, her z-score was her score, which was 40,
Minus 35.
minus 35. It's going to be 3.
No, divided by 3.
It's
It's going to be 5 over 3.
Which is 1.66.
Yes. No, I mean, I got 1.6 on So it's quiz 2, right?
So quiz 2, yeah.
Because,
Since
so the greater the z-score,
the better you did in relation to everybody else.
so you're like in a greater percentile.
Yeah, exactly.
That's how I think of it, because like that's the first one was exactly 1 standard deviation, so that's in the 34%. And then because
Six-
this is
yeah.
more than 1, it's a little more than 30.
Higher z-score
So higher z-score.
is equal to higher percentile. That's very correct. Maybe higher is wrong here. Larger? Bigger?
Yeah, probably larger z-score.
Either way. No, but like -1 is larger than -5.
I think it's fine. Larger z-score is equal to higher.
The test 2.
Greater z-score. That's the best one of all. 37 is the one that got erased. So I'm going to go ahead and redraw. 37, we're looking at a...
Wait, you did all this in one period? Yeah.
They didn't take a 2-minute break.
It was a 2-minute break, yeah.
Late also.
No, it started late.
No, we waste a lot of time in period 4, though.
No, we don't. We have
I
so
think we
many
do.
questions.
I think we do. We waste a lot of time in period 4.
I thought today was very productive.
Right?
Yeah.
All right, 90th percentile. I'm going to pretend I know where that is. I'm going to pretend it's right there, 90th percentile.
Did you just say that you took it out?
Hmm?
You just said that you took
No,
it
it
out.
accidentally like.
I accidentally deleted it. All right, so the percentile is the area to the left. So the area to the left of my 90th percentile is 0.9, which means the area to the right of the percentile is 0.10, but we don't actually need to worry about that right now. But we can figure out the z-score here using an inverse norm. This is chapter 7 work, yeah. So if we did our inverse norm here, inverse norm,
Before you continue, can you explain why we did it inverse? Yeah, why exactly scores that you can find. They can differentiate.
So the inverse norm only does one function. Only thing that an inverse norm will do is give you a z-score.
Because we have the area.
Yeah.
Okay.
How do we get to this?
And wait, and then on the normal CDF, on share. Normal CDF gives you the percentage.
So what is
Same way.
area mean instead of
What do you have? 83.
And for area, you put
Just
like
put in
9.
the area that's it.
hold on one second.
Always area to the left.
It's always area to the left.
Yeah.
Bree?
Um,
When you have
You go to 7 bars.
83, what's the order that
It's the same thing.
And I just put in, well, what is it?
0.90.
It's inverse norm, and then this is the area to the left. The 0 and the 1 are actually optional.
So when we're looking for the z-score and we have the area,
Yes.
we do inverse.
Exactly.
Do we
Never forget that.
Wait, do we I'll forget that tomorrow, but I'll remember it.
Don't forget that.
So just in general, when we're calculating the z-score, it's x minus mean over standard deviation?
Yes.
I got
Brandon.
1.3.
wait, oh, I found it.
Okay.
Why aren't we putting what's 48 and 7 into the mean and standard deviation?
Because I'm gonna pretend that that doesn't exist. You can play with that if you like, but I'm not gonna play around with that.
It's always 0 and 1. It's always 0.
Okay, so 90th percentile means you did better than 90% of the students, right?
Yes.
So if we're trying to find 90th percentile, why are we taking 90% and not the 10%?
Our calculator only does
Left
area to the left. Yeah.
Okay. So if it's asking us for the best 10 or the highest 10, we would take the 90th and just put 1 minus that.
Yeah.
Yeah. 1 minus that.
No. Not for z-score.
Yeah, that
for
would make sense.
for inverse norm, you just do area of point or inverse norm of 0.9.
And if
Okay.
it's asking for the worst 10%, you just take 10.
Yeah. Inverse norm of 0.1.
So either way, you just take 1.
Kanan.
Since this is asking for a score,
Yeah, we're not done yet.
okay.
Yeah. We're just spending a lot of time with the calculator right now. We'll get there in 1 second. All right, is everyone okay getting the z-score? Okay, we have a z-score of 1.28. How do we get her test score?
Z equals like x minus observation equation.
Yeah. The z-score equals the measurement, her test score x, minus the mean over the standard deviation. Now, I don't care how you solve this. Repeat, I don't care how you solve this. As long as you actually solve it, you'll get x equals 56.96.
So, Mr. Pereira,
Yes, Griffin.
are we allowed to just plug like 48 and 7 straight into the calculator?
I'm not going to, but you can do that if you understand how that works.
Okay, so,
I'm not going to talk about it.
okay. Yeah,
Okay.
it works, I got it.
Okay. Any other questions? Awesome. We're gonna move it. Move it.
No, man, I'm so paranoid.
We're gonna move on to 38.
Just go back there.
All right, I'm gonna hang out here for a couple of minutes then. Okay.
Sounds good.
Take a break.
Yes.
The
area to the left.
37. Does anyone get it?
Recycle it? Recycle it trash. Recycle.
If it said like, say it said,
Why are you
point 10 better than her? Why? To explore you guys, we still use 0.9.
Your base.
You have to go by Christmas.
So why? Dude, I'm Jewish. My parents don't let me get a Christmas. I haven't Hello. Wait, I'm running for 37. What it was. I told my
Yeah, you have to put that.
go take care of our little goat now.
See, I just found out that her name is Emma, and I haven't bought my
Oh,
camera.
man, you decorate and then you stare at it.
Well, I wanted to know what
The worst
I
thing
didn't know
is
French.
decorating your tree.
I'm gonna buy this.
No, can I just tell you something?
No. Anyway, I said no.
My mom
I
was
said no.
Shut up, my
I
mom
said she don't get it. I said no.
Hey, mama talking to you. My mom wants to put up Christmas lights on the house, but she doesn't want to get a Christmas tree.
I want Christmas. What they don't.
No, they're like like I have one of my friends.
Okay, I think we're ready to go. Thanks for waiting.
No,
Good.
it's not. She doesn't care.
37. Let's take a look at 38. We still have about. We still have a few questions to go here. Actually, not that many, but we're almost done. Look at 38. 38. Given the frequency table above, what are the mean and median of the distribution? Ooh, that's a difficult question to ask. Let's see what we can do. The median is going to be the 50th percentile, right?
Wait, isn't there a short way to just put it in the calculator and it tells you?
Not everything's like that.
No, I swear there was, wasn't there?
Not from this. Not from a cumulative.
Wait, isn't it just like you? It's just like a normal thing. I don't. I just got it like that.
Alright, go ahead and square. It's just a problem.
Okay, so let's make a distribution. Let's make a distribution table here. We're gonna have 5. No. We're gonna have the relative frequency, right? And then the cumulative relative frequency. Why do these words have to be so long?
Right.
We should just put R app and see.
No, the people
You know, it's really funny that my computer now, it tells me that I have a I don't have a genuine version of Windows.
Yeah, it told me that too. Why does it do
It's
that?
like, hello, this is like a factory installed Windows. Why?
My printer
So
like
annoying.
randomly like makes a notification saying you have a genuine ink thing.
Because you're not nice to your printer.
Stupid. You know, I blame Apple. I do. I completely blame Apple for this.
Why?
Because remember when they started doing, you have a non-Apple charger cord?
Oh, yeah.
Yeah, and it made it okay for everybody to do the same thing now. Because, oh, you'll take that crap from Apple. You'll take that crap from us. Apple.
But still, even if you do like the non-Apple ones, they still
Like
work.
You're right.
Guys, Brett has to go get a Christmas tree, so he wants us to really
I'm
get
so
that.
sorry.
I know the,
Right, don't you sell
the class
Christmas
itself
trees?
has a giant like form of ADD. But
You're-
let's like focus up real quick, okay?
You're so right.
Right? Like,
That was a good pep talk.
Oh, Nicole liked it. Nicole thought it was fun.
Nicole, text me later.
Okay, relative frequency here. Okay, so the class width, this has got to be 0.15, right?
Yes.
Yes.
Yes, okay. This one has to be, I think, 0.07, right?
Isn't the other way?
We're reverse engineering here, right?
What are we doing?
No, I don't know, because that was the one that adds up to 1, and those are the ones that add up to what it's going to be.
So again, we're getting the relative frequency based on the cumulative frequency. Okay? All right, so 22 plus something is going to be 55, right?
33.
That's going to be 0.33.
0.4.
Yes, again, people.
Okay, okay, where is the median going to be? The median is going to be the 50th percentile, right? Or the 50th relative, 0.5 relative frequency, right? So it is going to be at 7, right? The median is going to be 7. Is the class that contains the 50th Yeah.
Middle. See, this is 0.55, that's 55th percentile, which one's the middle? Yeah. So you go 55, and then total
Okay. And that's going to be at 0.7.
just that.
I'm sorry, median is going to be equal to 7. Okay?
So let's say that 0.55 was actually, like, even at 5, then 5 would be the median. If the cumulative relative frequency of 5 is 0.55, then 5 would be the median.
Okay, and as far as the mean goes,
It's 7.8.
I don't have a good way of figuring out the mean from this.
Can't you just add them all up?
Yeah, that's what I did.
Shouldn't be able to.
Can you multiply like 0.5
Yeah,
or
but then
5 times
Oh,
1.5 and then
yes.
Isn't the mean 7?
It's 7.8.
To find the mean,
Whatever.
you're going to treat this like a what's the word? Not Democrat. Discrete. Thank you. Okay. So the mean is going to be equal to 5 times 0.15 plus 6 times 0.07
No, that's unnecessary.
plus 7 times 0.33 plus 9 times 0.40 plus 12 times 0.05. Hey. No.
Why are we doing it like this?
This is the only way we have.
Do you divide it by 1,000 then? No?
No.
Oh, I did the wrong thing.
But by doing that, aren't you just adding up all of the frequencies?
You can have done that.
We're adding and weighting the frequencies. Okay. Okay.
Divide by anything?
No. No. If you're doing a weighted average, you don't have to divide by anything. That was funny. Okay, let's move on to 39. At a local community college, 30% of the students take calculus. 80% of those who take calculus take science courses, and 40% of those who do not take calculus take science. Woo!
This looks like a chart.
coming on.
This sounds like a chart. Yeah, it is a chart. Good. Excellent analysis. Okay.
Team awesome.
Let's get our chart together. The first thing is calculus, and then no calculus. Next one is science. Next one is no
Why
science.
do you put a sad face next to no calculus? That should change that.
What's the dot?
Happy.
That's just placeholder.
Mary, no one cares about
Last one's total. And of course the total has to be 1.00. Hopefully you've seen me do these charts like hundreds of times by now. You know what I'm going to look for first. I'm looking for one of the probabilities that is not linked with the other event. Okay. 30% of the students take calculus. Perfect. Not linked to science at all. Just 30%. 0.30. Meaning
0.70 for no calculus.
0.70 for no calculus. Exactly.
Brandon's hungry, just don't talk to him.
0.70. Now we can go to the other ones. Let's see. 80% of those people who take calculus take science. So 80% of the 30%. Whoa.
Oh, I get it.
Oh.
80% of the 30% are going to take science. 0.24. Okay. Which means you can get this number here. That's 0.06. Okay. Next, 40% of those who do not take calculus will take science. So 40% of the 70%.
I like this thing.
40% of the 70%. And then again, by complementary rules, you should be able to get this. So that's what, 42? Okay, now you have all those. You can get the total number of people who took science. Let's see. Percentage here is 52.
I know 40.
0.48. Question asks you, what's the probability that a student takes science?
52.
That was what, 39? And 40. What's the probability that a student who takes science also takes calculus? Wait a minute here. We already know that they're taking calculus. No, we already know that they're a science class, right? So what's the probability of the calculus given that they're taking science? What's the probability of calc and science divided by the probability of science? I don't know why I put psi.
Wait, why don't you just look at the chart and say 0.24?
Because that means that they took science and calculus. While the question is asking, what's the probability that they take calculus given that they take science?
Okay. Subtly different. Actually, maddeningly
It sounds
subtle.
the same though when you say
Yeah,
it. Like,
when I read it, like how would I say it?
Right, it really does sound the same.
Yeah. The way to interpret this correctly is that you already know that they take science. If you already know they're taking science, then it's a conditional probability.
Also takes.
The student who
Yeah.
does take science takes calculus.
How would it be worded if it was just if I just looked at the chart?
Probability of a student who takes science and calculus.
Okay.
Okay. 41.
Oh, that was 40. Good job.
41. We have one of the values in a normal distribution is 13, and its z-score is negative 0.210. If the mean is 16, what is a standard deviation? You know, they're practically telling you the equation here, aren't they?
Yeah.
Okay, the z-score is negative 2.10, right? And that's equal to
13 minus 6.
the value, which is 13, minus the mean. What is the mean? 16 divided by the standard deviation. Yeah, now you just solve that. So it's just what, 13 minus 16 divided by negative 210? Here's our standard deviation.
For standard deviation, how do you round it? 4?
You do it based on the mean.
Oh, wait, you mean what?
So our mean was 16. So you only need to get you only need to go to 1.4. You could go to 1.42 if you wanted to, but 1.4 is the only one necessary. Okay. Hey, 41, not bad, right?
not bad, not bad.
42. The weights of professional football players are approximately normally distributed. I don't believe that, by the way. With a mean of 245 and a standard deviation of 20 pounds. Thor is in the 80th percentile. What is his weight?
So you have to draw a graph.
So yeah, you know, drawing a graph is a good idea. Let's draw our graph. We have a normal distribution. Okay, draw the hat. Let's figure out where the mean is. The mean is 245, and we're going to put it over here in the middle. 245 with a z-score of 0. Thor is in the 80th percentile, so I know it's on the right side here, right? Yeah. The median is the 50th percentile, so it's got to be over here. This is the 50th percentile. So the area here is 0.8.
When you find the z-square, the inverse norm.
The area of this blue here is 0.8.
So you could do inverse norm 0.8.
Perfect, perfect. The z-score is going to be the inverse norm of 0.8. The area of the blue areas of blue is 0.8. So the z-score is going to be equal to, let's do this on the calculator, inverse norm. Oh, hey, it's already there. I just got to change that 9 to an 8, right?
Yeah.
You guys know my stomach would stop off.
0.84. I'm going to put a question mark here. Okay, 0.84. So we know Thor is in the 80 has a z-score of 0.84. We just need to find his actual weight now. Exactly, the equation. How much does he weigh? We don't know, right? Minus the mean. What was the mean?
Mean was 245.
Good.
Divided by over, yeah, over 20.
Divided by a standard deviation of 20.
So if we look from our calculator, do we need to show the work like that?
No.
Okay.
He's approximately 262 pounds.
Okay. Yeah, so we can solve that now, right? And
261.
so x equals
261. 261.8.
yeah,
Question.
lb's.
If you
Yeah.
were doing previous ones, would you do 262? The mean is 245.
He weighs more than
No, I would put 0.8.
Okay.
Okay. Does it make sense? Should he weigh more than 245?
Yeah.
If you're in the 80th percentile, yeah.
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 That makes a lot of sense. Oh, shit.
Right, any questions on 42? Okay.
3 more questions.
Yeah. 3 more. Probability density is given. What is the expected value? Okay, remember that expected value is equal to the mean. So it's going to be the mean is going to be equal to 3 times 1/3 4 times 1/6 1/2. Yeah, 4.1667. If I did it correctly.
Yeah, that's correct.
Yeah.
Why is expected value mean?
By definition.
Damn it.
So if it just says what is the expected value of x, we just calculate.
Find the mean, yeah.
And also, can you go for for the FRQ tomorrow? The z-score, we do 2 decimal points.
Yep.
We do 4 decimal points.
Yep.
That's it.
Mm-hmm.
Wait, Z square is 2.
Whatever.
The other one, what was the other one?
Standard deviation score.
Oh, and we don't want us to put scientific notation, right? For grades.
Yeah, I would prefer if you didn't use scientific notation. 44. What is the probability that x is at least 2.5? So the probability that x is that greater than equal to? 2.5. All right. So which of my outcomes are greater than 2.5? All of them.
How would we do this? Do we do normal or binomial?
Oh, it is all of them, isn't it?
Right, yeah, I was like, what do you?
When our someone said no, bro, I was like, okay.
How did how did the answer get 2/3?
I was stupid. I didn't understand that. Yeah, it makes 3, 4, 5. They're all
3, 4, 5. At least 2.5. That's all of them. The probability is 1.
Wait, then why does it say 0.6667?
I have no idea.
Maybe meant to say like 3.5. Is that
How would we find it equal to 1?
Because it's 100%, so it's equal to 1.
Oh yeah, that's right. It's for sure that they asked for 3.5.
Hang on one second. Maybe there's a typo here. It's 0.6667. That's 2/3, right?
It's 3.5.
Okay. All right. So I think the typo here. The typo. Okay. At least. Sorry. Okay.
Brett's trying to leave.
It's 0.667, right?
So 3.5?
Yeah, at least. It's supposed to be at least 3.5. Okay. And we're so lucky. Next year they'll get that fixed.
So
So in that case, you would just add 1 over
Yeah.
6 and 1/2.
So let's do that. The probability that x is at least 3.5 because we've got to look for all of the outcomes that are greater than or equal to 3.5.
Probably 4 and 4.
So that's just 4 and 5. And that's equal to 2/3.
Wait, so we're not finding 2.5?
Well, there is no 2.5.
Oh, because I thought it was a typo.
That was a typo, yeah. Yeah.
Your calculator only finds less than or greater.
Only finds less than equal to.
what was the thing where you had to do 1 minus less than?
That's what
That's
I'm
to get
saying.
greater than.
And that's for binomial.
45. What's the standard deviation of x? Yikes. 45. Standard deviation. Okay, so let's remember standard deviation or variance is going to be equal to 1 over n, I think it is.
What? How did you get the variance?
Hang on.
Brandon, why don't you just be patient?
Times the sum of x minus mu squared
That's me.
times probability of x. O is a typo. Oh wait, no, there's no 1 over n. It's just that.
So what's the x times the mean minus the median square?
So what was our mean?
It was 4.1667.
Good. Okay, so let's do this then. There's only 3 numbers. We can do this. Okay, so the variance equals. The first one is 3. Yeah. 3 minus our mean squared times the probability. What's the probability of 3?
1/3.
Times 1/3. Plus, next one is 4 squared. What's the probability of 4?
1/6.
Plus
5 minus
5 minus the mean squared.
Can you not ask this on the test?
Isn't this like
so much work.
Share is straight.
King, what's the easier way?
Okay, let's do this on the calculator. On the calculator, let's clear our lists. Start with clear all lists.
Whoa.
Let's take a look at our list here. L1, we have 3. What are we doing? Three, 4, and 5? Okay. And then the probabilities here, 1/3, 1/6, 1/2. Okay. Let's go to the home screen. Wait, you know what I should do? I should screenshot this. Screenshot.
That was like 20 minutes.
That's what you say.
Okay, and then on the home screen, we're going to go ahead and do the following. We want to add, so sum. Shoot, sorry, hold on. Let me clear the home screen a little bit. We want to find the sum of L1 minus 4.1667 squared times L2 standard deviation.
Is that variance?
That's variance, yeah, thanks.
Wait, Barry, is this the last problem?
Yep. Here's our variance. So variance equals 0.80555. So standard deviation is equal to the square root
Is there anything really hard? It's all. Oh, right.
Isn't it math?
done. Yeah. Binomial. Yeah, we can do that.
So, instead of doing all that, why didn't you just make these, like, make up the sample?
What do you mean?
I don't know, just like, I don't know, multiply all the probabilities by 6 or something, and put that number of each value in a list. I mean, it would have saved you a lot.
Yeah, show that to me later.
Okay, yeah.
How do you go to sum again?
Sum is list math. Okay, any other
I
questions?
just
Yeah.
have a couple questions. So, in word problems, how do you know when to use binomial CDF or normal CDF?
Whether it's binomial or normal.
Well, would it explicitly
No.
explicitly state normal?
No. Well, it would have to say normal. Okay. For binomial, it has to qualify with those 4 things. Problem. Let's see. Problem. Yeah, let's see. Well, let's get a binomial problem here. Okay, so there are 10 basketballs in a bin. Okay.
So the number of Charles is
Oh no. Let's just say there are 1,000. Okay? That's 10,000. Basketballs in a bin. Let's just say 16 of them are underinflated. Okay. If you take out 5 basketballs at random, is the probability of getting, let's say, A, 3 underinflated balls. At least 2 underinflated.
That word is
So what?
underinflated. Like it's just,
But they're not necessarily
She
flat.
can't deal with many syllables. It's really hard for her to like say and think about it. So.
Right.
You know?
Right. Got it. Got it. Okay, so the last one, not the last one. The first underinflated ball selected will be the, I don't know, 5th ball. D.
It's a binomial. Are you still recording?
Yeah.
Yeah.
The first underinflated ball.
Okay. Assume the trials are independent. I couldn't say there's an infinite number of basketballs in the bin. That's kind of ridiculous. But 1,000 basketballs, I mean, that's a really big bin. Probably as big as the gym. But what do you do? Okay, assume that trials are independent. Let's take a look at the first thing to realize for parts A and B.
Is that the probability is 0.016?
No, isn't it that A is PDF?
For parts A and B, we have a binomial distribution. X equals 5. And the probability of success, which we're calling pi. Thank you. That's the problem right there. Pi is 16 out of 1,000. What was 16 out of 1,000?
0.016.
0.016. That's really small.
Yeah. So your thing is gonna be small too.
Yep.
That's fair. It doesn't say it's normal, we could just assume it's binomial.
Well, no. You can't assume either of those. If it's normal, it has to say normal.
So what seems this makes you say it's binomial?
Binomial, it has to satisfy the 4 conditions. Probability of success doesn't change.
Why is X
Trials are independent. We're interested in we have a set number of trials, and probability of success doesn't change. Okay?
Oh, 16
For 1,000 multiple.
Not enough.
So X stands for total amount of rolls.
I'm sorry, that's supposed to be an X, it's supposed to be an N.
Yeah, it's an
That's why I was confused.
Okay.
number of trials.
Yep.
Yeah.
Okay, 3, exactly 3. We want to know what's the probability that X is equal to 3. Oh, sorry, we have to write this. X is going to be equal to a binomial distribution with 5 and 0.016. Okay. This part is true for parts A and B. Part A, what's the probability that X equals 3? That's just from the calculator.
3.96.
That's going to be equal to, well, we could write it down. It's 5C3 probability of success is 0.016 to the 3rd power. Probability of failure is 0.984. And we want 2 failures. Calculator, we're just going to go ahead and go here. And we're going to go second distribution. Binomial. Now this is a PDF. 5.
If it says at least, then you just see it.
There you go. 0.00003. Okay. Let's screenshot this for the benefit of all. Okay, part B. We want to know the probability that X is at least 2. That means greater than or equal to 2, right?
It means greater than 1.
At least 2. That means greater than or equal to 2.
Yeah, you have to then change that to greater than 1. Yeah.
Okay. So it's got to be less than or equal to 1. And let's go ahead and do this on the calculator. That's going to be 1 minus, and again, binomial CDF. 5 trials, probability of success is 16 out of 1,000. And we want to know, I think we said 1, right?
Yeah.
So when you put CDF, it automatically knows to be less than.
Yes, less than or equal to.
Okay.
Oh, sorry, what was that?
When you do 1 minus the
0025.
I got 2.5. Yeah, 2.2 to the negative.
Okay.
Huh?
Why is it CDF? Oh, I'm retarded.
That's pretty hard.
C. Okay, the first success is going to happen on the 5th ball, right? So now we have a geometric distribution.
Good luck in your game.
X is equal to a geometric distribution where the probability of success is 0, 1, 6. If I remember correctly. Okay, so we want to know the 5th ball probability that the first success, the first underinflated ball is the 5th ball. That's going to be probability of failure, which is 0.984. We want 4 failures. And we want 1 success.
Sorry, after this, could you just go back to the questions?
Which is, yeah, give me 1 second. 0.984 to the 4th power.
Why is it
0150. And let's screenshot that. And I think the last one that we're looking at here. Oh, so you want to look at that question, right?
First underinflated ball would be
I'm guessing that's the
why do you change that?
We're just gonna have to make that as an assumption because there's 1,000 balls. It's not gonna change all that. Yeah. No. That's something you have to come up with. Okay, let's do this one. The first underinflated ball will be after the 3rd ball. So in other words, we're going to get 3 properly inflated balls. Failure to the n-1 times success.
So now it's at least 3.
No. After
This means that the first 3
are gonna fail.
trials must be
And then we don't know after that which one's gonna succeed.
failures. Yeah, after that, we don't care. We just have to make sure we get 3 failures. So this is going to be equal to failure, 0.984, to the 3rd power. I don't think we need the calculator for this.
You only multiply by a failure, and then that's
Yeah.
okay.
Because
But if it had greater than or equal to, would it make a difference?
Did your
Yeah,
calculator
it
do that for you?
does make a little bit of slight difference. Because if you want to know the 4th one or more, then that means you only have 3 failures.
If you want to know the 3rd one greater than or equal to 3, then you would.
You only have 2 failures.
Oh, okay. That's
So
what
just
we
count
did.
the failures.
That's what we did.
Yeah.
How do you know if it's geometric? 'Cause I know how you know if it's geometric.
Geometric is just like binomial, except for there is no set number of trials, and you're interested in the trial number of the first success.
So geometric has successes, right?
Geometric is when does a success happen. Binomial is how many successes. She's telling me what happened on Ellen. Ellen gave away all remastered records of the Beatles and a record player.
I love Ellen.
I don't know, or
I don't need it, but I love her. And Chelsea.
okay. That's where I'm gonna stop it. Good luck tomorrow.
Thanks. You too.